Greetings, mathematicians. Welcome to this narrated PowerPoint looking at factorising cubic expressions. Yes, just a bit of knowledge that you need to know, strictly on a need-to-know basis, and you need to know it. Teacher. Yes, why do you need to know it? Because we need this knowledge for calculus. Moving steadily along. A cubic expression is an expression where the highest power of x is an x cubed, like that one. That's a cubic expression. So how would you factorise an expression like that one? Well, before we factorise cubic expressions, let's just recap how we would factorise squared expressions, aka trinomials. There's a trinomial. How would we factorise that? Something like this. Something to note, the negative 2 times the 4 gives us negative 8, because the negative 2 and the 4 are both factors of negative 8. Remember that. Don't you forget about me. Thank you. So if this was a quadratic equation that we were trying to solve, if this thing here was a quadratic equation, the answers that we would derive from these brackets would be x equals 2 and x equals negative 4. Do you notice how the signs are reversed? So if that's a negative 2 here, it'll be a plus 2 when we write it as an answer. And if this was a plus 4, it'll be a negative 4 if we were to write it as its answer. These numbers, these answers, are called roots of this expression because they are the values that when I substitute them in here make the expression equal to 0. So let's move on to factorising our cubic expression. There it is. Now, firstly, in our trinomial, remember we noticed that each of the roots was a factor of the constant. So it's going to be the same here. All of our roots, all of the numbers that are going to go into the brackets are going to be factors of this 6. So what we're first going to do is list all the possible factors of 6. There they are. It could be 1 and 6, 2 and 3, or remember it could be negative 1 and negative 6 because two negatives will also give us a positive, or it could be negative 2 and negative 3 because they will also give us 6 if we multiply them. So the list of possible roots are these: 1, 2, 3, 6, negative 1, negative 2, negative 3, negative 6. These are all the possible roots, the possible numbers that could be in the brackets that we'll get when we factorise this. So what we do is we choose one of these numbers, any one will do, and substitute it in place of the x in our expression to see whether it totals up to 0. If it totals up to 0 when we substitute one of these numbers in, that means that that number is a root. If it doesn't total up to 0 when we substitute one of these numbers in, then it means that that number is not a root. So let's just choose 2. I'm just choosing one at random, doesn't really matter which one we start with, and we substitute it into our expression. There we go. And what do we get? Negative 4. So that means 2 is not a root because it doesn't total up to 0. So let's choose another number. How about 1? So I'm going to substitute the 1, which was on our list of possible roots, into our expression, substitute it in, and what do I get? 0. So that means 1 is a root of this expression. Right, so you will have remembered that in a trinomial it generally factorizes into 2 brackets. A cubic expression generally factorizes into 3 brackets. And because we know that 1 is a root of our expression, we now know that what goes into one of those brackets. It's going to be x minus 1. Like with a trinomial, if the root is 1, what goes in the bracket has the opposite sign. So x minus 1 is going to go into our bracket. So we've solved what goes into one of our brackets. We don't know what goes into the other 2. What we could do at this point is go back to all of those numbers from the list of possible roots. You could carry on substituting them into the brackets until you've filled out both brackets. But 2 problems. 1, that takes a long time, and 2, and more importantly, it doesn't always work. So we need another method to figure out what goes into these 2 brackets. That other method is this. If I was to multiply these 2 brackets together into one bracket, they would give me a trinomial. So the product of this bracket and that bracket, we don't know what it is, but we know that it would be a trinomial. And we know that this trinomial, the mystery trinomial that we get here from multiplying those 2 brackets together, that mystery trinomial multiplied with this first bracket must give us our cubic expression. So this small bracket multiplied by the mystery trinomial there must give us this. So now we need to work out what is this mystery trinomial. Well, there's some parts of it that are quite easy to deduce, because we know that that x times this must give us x cubed. So that x times whatever goes there must give us x cubed. So what must that number be? X times what gives me x cubed? It must be x squared. So that's what we know so far. Then we can look at this last number, because we know that this -1 there multiplied by that number there must give us +6. So that number there multiplied by this number here, if I was to do FOIL and multiply all of this out, that times that would have to give me +6. So what number must that be? It must be -6. So we know that much. So we're 2/3 of the way there. So we've got this far. We know that this first term in the mystery trinomial must be an x squared. We know that that third term in the mystery trinomial must be a -6. But now what is our middle term? So now we need to do some thinking. We do know that if I multiply this -1 with this x squared, remember, if I was doing FOIL and trying to multiply out these brackets so that I could get this as my answer, I would have to at some stage multiply this -1 by that x squared. And that would give me -x squared. However, if we look in our original cubic expression, it's got a -2x squared there. So I need to know what else must I combine with this -x squared so that I end up with a -2x squared. Well, it must be another -x squared, because -x squared minus another x squared would give me -2x squared. So that is telling us that this middle term in our trinomial times that x there has to give us a -x squared, so that this -x squared and that -x squared will combine to give us the -2x squared that is in our original expression. So that times this has to give us -x squared, which means this middle term has to be a -x, because x times -x gives us -x squared. There we go. So we now know what this trinomial is. All we need to do now is factorize this trinomial into its two constituent brackets. There we go. This trinomial factorized gives me that. So here, these three brackets, that is the final factorized form of this cubic expression. There we go. Okay. Example number 2, factorize it fully. Right, you can try this one yourself. Give it a go, pause the video, try it, and see how you do. Right, now that you've tried it yourself, let's have a look at the answer. First, we have to list all the possible factors of 36, and there are a lot of them. It could be 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6, or it could be the negatives of all of those, because remember, a negative times a negative also gives you a positive. So let's list all the possible roots. It's a lot of roots. That's a lot of possible roots for this expression. So now we choose one of them, any one, and substitute it into the expression to see if it will give us 0. I would discount these big ones to begin with, because we're not dealing with huge numbers here. Also, because that's a 36, I think the chances of the roots being a 1 or a 2 are also pretty slim. So I'm going to start with a number somewhere in the middle here, and we will find that 3 is a root. There's one I prepared earlier, as they say. So 3 is a root, which means one of our brackets is going to be x minus 3. Remember, the number in the bracket has always got the opposite sign to the value of the root. Now I need to work out what would go in this mystery trinomial so that this bracket times that trinomial gives me our original cubic expression. We know that that times the first term of the binomial multiplied by the first term of the trinomial must give me that x cubed from there. So what must this number be? It must be an x squared. Then we know that this -3 here multiplied by this number over there must give us the positive 36. So -3 times what gives me positive 36? It must be -12. Now I need to work out the middle term. So I just look and see. If I went this -3 multiplied by that x squared, it would give me -3x squared. But if I look at my original cubic expression, I need to end up with -2x squared. That's what I need to end up with. So what do I need to combine with this negative 3x squared so that I end up with negative 2x squared? Well, I'd have to add an x squared, because negative 3x squared plus an x squared gives me a total of negative 2x squared. So now I need to ask, what must this middle term be here so that when I multiply it with that x over there, it gives me x squared? The answer is positive x. Right, now that I have my trinomial figured out, I just have to factorize this trinomial. And there we go. You will notice here that I've got two identical brackets, an x minus 3 and x minus 3, and then an x plus 4. This is an example of a cubic expression that if you try to factorize it by just repeatedly substituting in possible roots, you would not get the final answer because we have repeated a root. So you would only find two numbers that give you a 0 when you substitute them in. If you went through that whole list, you would only find two of them give you a 0 because one of these brackets is repeated. So this is a reason why we use this method and don't just repeatedly substitute in roots. All right, example number 3. There it is. You try it yourself. Try it yourself. Don't be lazy. Right, and now that you've tried it yourself, let's have a look at the answer. First, we have to list the factors of negative 3. It's easy because there are not many of them. It's either 1 and negative 3, or it's negative 1 and 3. Both of those combinations will give me a product of negative 3. So the list of possible roots is 1, negative 3, negative 1, and 3. And I've done the work for you. Negative 1 is a root. So we know that one of our brackets must have x plus 1 in it. All right, are we happy with that? So now we need to find out the trinomial that goes here. Again, we say that times this term must give me x cubed. So what must this term be? It must be an x squared. Then we say this number here multiplied by that positive 1 must combine to give me a negative 3. So what must that number be? It must be a negative 3. Then we move on to say, well, this middle term here, how do I work that out? Well, I first look at these two. The 1 times the x squared gives me x squared. But in my original cubic expression, you will notice there's no x squared at all, which means the value of the x squareds is 0. So I need to ask myself, this x squared combined with what would give me 0? The answer is a negative x squared, because x squared minus x squared would give me 0. So this x times that middle term has to give me negative x squared. So what must that term be there? It must be a negative x. So there we have it so far. We have one of our binomials figured out, and we have a trinomial there that we have to factorize. You will have found when you tried this that you can't factorize this normally. You have to use the quadratic formula. So we use the quadratic formula and we get these answers. Now do note that the quadratic formula gives you the roots of that trinomial. We have to change the signs when we put them back in the brackets. So when you did the quadratic formula, you would have got positive 4,61 and negative 2,61, but we've got to change them to the opposite signs when we put them in the brackets. This is another example where you have to use this method of finding the trinomial first. You can't just keep substituting through the roots, because you will only find one of these numbers substituted into here. It gives you 0, because the other two roots are irrational numbers. Before I leave you, for posterity, an organ swell. Okay, bye-bye.